All right, good afternoon. Today I'm going to talk about 1.2 characteristics of functions and graphs. Okay. You can identify several attributes of a function by analyzing its graphs. For instance, for the graph shown, you can see that the function's domain is x such that x can be any value between 0 and 11. So you can see that here. So notice if you put in a 0, you get an output of -1. If you put in 11, you get an output of 11. The function doesn't keep going either way, so the domain is restricted. And its range is the smallest value that can occur is -1. The highest value that can occur is 1. So the range is between -1 including and +1 including. Use the graph to explore the function's other attributes. What is the function doing on the interval 1 to 3? So if we look at it from here to here, what is our function doing? Well, our function's outputs are up here. They're positive. Do you guys see that? So we would write it is positive. Okay. Down here, what the values of the function on the interval 8 to 9. So 8 to 9, your function is down here. Okay, it's down here. So your values are negative. Okay. All right, now getting a little more in detail. A function is increasing on an interval if the function of the first closest value to 0 is less than the f of x, another value that's further away from it, when x is less than x2 for any values x1 and x2 from the interval. In other words, the function increases from left to right. So you want to see if you have an x over here and then you have an x over here, is the value increasing or is it decreasing? All right, so let's kind of like talk about it. So it's decreasing basically if the line's going down, right? So let's actually look at it and put that into action. So here's our graph. The given function is increasing, decreasing on the interval 2 to 4. So we're going to look at this 2 to 4. Well, where are our outputs? Our outputs, if I look at this x at 3, then I look at it again at 4, what happened? My function went down. So the function is actually decreasing. Okay. Now, given the interval 4 to 6, so we're going to look from here to here, and I look at an x over here and I look at an x further along, what is my line doing? It's increasing. So it's actually increasing. So that's all it says. All right. You guys hopefully remember slope. This is the fancy way of writing it, but you guys hopefully recall it as y2 minus y1 over x2 minus x1. Okay. It's just now that we're getting further along in math, we want to name it with that function notation. Okay. It's just a name of a function. All right. So let's go ahead and calculate these things. So what is the given function's average rate of change? In other words, slope on the interval 0 to 2. So we're looking from 0 to 2. Okay. So I'm just going to use the values that are given, right? So f of 0 is what? F of 0 is down here at -1. And then what else are we looking at? F of 2. And f of 2 is way up here at 1. Okay. And then what were those x values? So I used x equals 0 and I used x equals 2. So now we're just going to plug it into our function. Or I'm sorry, our slope. So we have slope equals my second value, which is 1, minus a -1. Okay. And then don't forget to pair that up. So my first value was 1. So my x is 2. -1, value is 0. And then we get double negatives here become a positive. So I get 2 over 2. Which is equal to 1. So the slope of the line on the interval 0 to 2 is actually just 1. Okay. All right, moving on to looking at some more characteristics of functions. A function may change from increasing to decreasing or decreasing to increasing at turning points. The value of f of x at a point where a function changes from increasing to decreasing is a maximum value. A maximum value occurs at a point that appears higher than all the nearby points on the graph. The value of f of x at a point where a function changes from decreasing to increasing is a minimum value. A minimum value will occur at a point that appears lower than all of the nearby points in the graph. I always use quadratics. Quadratics are the easiest to kind of look at. So, you know, a minimum point means that it is the lowest point that is by everything else, right? So you can think of it as like if you use the quadratic f of x equals x squared, this value right here is the smallest. Okay, so that's what they mean by minimum. Okay, whereas the maximum point is that top point. Okay, so all the other values are smaller. So the biggest. All right. So let's go ahead and look at this and answer some of the questions. So at how many points does the given function change from increasing to decreasing? All right, so now we're actually going to have to do some counting. All right. So how many points does it increase from increasing to decreasing? So right here, it's increasing. Oh, it's decreasing. So that's 1. Increasing, decreasing. That's 2. Increasing, decreasing, 3. So I get 3. Okay. Next question. What is the value of the function at those points? All right. Well, where does it change? It changes up here at the value of 2. Oh, I'm sorry. What is the function's value? Sorry. What is the value of the function? I'm just looking at x. So the value of the function is y. So all of those points occurred where it switched was at 1. See how it started going down? See how it started going down at 1? Started going down at 1. So your answer here is 1. Okay. Sorry, I was thinking of x, so we're actually looking at f of x. How many points does the function change from decreasing to increasing? Okay. So now we're going to have to count. And so where do we notice that the function is decreasing and then increasing? So I have decreasing. Oh, it's increasing now. So that's 1. Happen again, 2. Does it happen again? No. So your answer is 2. Okay. So from increasing and then it all of a sudden starts to decrease. All right, next one. What are the values of the function? So we're looking at f. So what are these values that it's changing? It's changing at -1. Okay. How many x-intercepts does the given function have? Remember, x-intercepts are where the line crosses the x-axis. So we have 1, 2, 3, 4, 5, 6. So there's 6 points. Okay, and what are those values? So it looks like we're at 1, 3, 5, 7, 9, and 11. So those are the those are the values of the x-intercepts. So, well, those are basically the values of x where it crosses. Okay. Next, we're going to talk, oh, that's it. I'm sorry. So 1.2 is pretty quick. All it does is talk about different characteristics. So we talked about increasing, decreasing. We talked about slope. We talked about minimum and maximum and turning points. And so that's it for 1.2. We'll now go into our classwork.